Chapter 3: Electricity from batteries applied to the roots of plants and the surrounding soil. In the previous chapter, we dealt with frictional or static electricity that developed by plate electric machines or drawn from the upper atmosphere, and which possesses high electromotive force but is very deficient in quantity, a little stream as it were, moving under great pressure. This, by reason of its great electromotive force, can penetrate the badly conducting air to plants and readily pass through them to the soil. Now we shall consider the uses of galvanic electricity, or that from batteries, in which, having low electromotive force, though capable of being delivered in large quantities, cannot be applied advantageously to the stalks of plants, but can be furnished readily to the soil surrounding their roots. A simple form of experimentation which first interested the writer, and which yielded in the main such favorable results that he was led to continue his investigations, was as follows. 2 boxes of like size were filled with the same kind of soil, and in each was planted the same number of hemp seeds at the same depth. They were exposed to similar conditions of heat, light, and moisture. In the end of one of the boxes was inserted a thin piece of zinc, the height and breadth of the box, and in the other end a piece of copper of similar size. Both were pressed down almost to the bottom of the box, and were connected above ground by a copper wire soldered to their projections. Thus arranged, the box was an earth battery, and the like of which has been used for running clocks and other machinery requiring but little current, and also by previous experimenters in electro-horticulture. The results were always in favor of the seeds planted in the earth battery, the plants resulting from them being from 20% to 40% in advance of those in the box without the zinc and copper. Briefly, what goes on in the earth battery is as follows. Some compounds in the moist soil act chemically upon the zinc, one of the results of which is that a current of electricity is generated. This passes through the soil to the copper, up the copper to the wire above the soil, and through it to the zinc, making a circuit. By inserting a sensitive galvanometer into the wire, current can be proved to be flowing by the deflection of the needle. It is this continuous current going through the soil which acts upon some of the compounds in it, and also upon the roots of the plant, giving us the good results we generally obtain. Ordinary galvanic cells, such as the gravity, can be used to furnish the current. All that is needed is to attach the wire from the positive electrode of the battery to the metallic plate driven into the earth, and the wire from the negative to a similar plate at some distance from the other one. More current is furnished, but the expense is much greater. The earth battery, in the hands of Ch3 in the botanical gardens at Kew, achieved some surprising results. He sank plates of zinc and copper about 2 feet square and connected by copper wires into beds, in which he planted various cereals and vegetables. He reported that in some experiments with cereals in these electrified beds, the stalks were 4 times as large, the yield of grain 1.5 times as great as in the beds not subjected to the electrical treatment. Let's read that again. He reported that in some experiments with cereals in these electrified beds, the stalks were 4 times as large, and the yield of grain 1.5 times as great as in the beds not subjected to the electric treatment. He produced in this electrified soil a radish 17 inches long and 5 inches in diameter, and a carrot nearly 11 inches in diameter and weighing 5 pounds. Both were juicy and fine flavored. Fisher and Waldstein experimented largely with garden plants, placing his copper and zinc plates, each 65 or 40 centimeters in the soil, 30 meters apart. In many plants, he secured an increase from twofold to fourfold. He claimed that the plants matured more quickly and agreed with Special that they were always free from disease, though often the surrounding plants were badly affected with fungoid growths. Professor Warner of the Agricultural College of Massachusetts has verified at the Hatch experiment station many of the results of the European experimenters and has given some very interesting ones of his own. In experimenting with lettuce, he prepared 2 plots in a greenhouse so that they would be subject to like conditions and influences. In the one he buried at a little depth in the soil a system of copper wires consisting of a series of from 4 to 9 strands 1.5 inches apart. He connected the wires with the battery of 2 cells, which sent a continuous current of electricity through them. These plots were in a part of a greenhouse which had been used for the raising of lettuce and in which great trouble had been experienced from mildew. One of his objects was to see if the electric treatment would have any effect upon the mildew. Equal number of healthy lettuce plants of the head variety were set in the plots. Those in the plot with the electric apparatus were planted over the wires so that their roots could come in contact with them. He reported that 5 plants out of 15 in the electric plots were killed by the mildew, the other 10 being well developed and the heads large. In the corresponding unelectrified plot, only 3 plants had partially developed and 2 of them were nearly destroyed by the mildew. Only 1 was free from disease. It was noticed that when the current became weak or was interrupted, the heads began to feel the destructive influence of the mildew. Also, that the largest heads were over the greatest number of wires and nearest where the wires were attached to the battery. A strange sight presented itself on examining the roots. It was found that they had grown about the wires as if they had found the greatest amount of nourishment. Professor Warner sums up by saying, everything considered, the results were in favor of electricity. Those plants subjected to the greatest electrical influence were hardier, healthier, larger, and had a better color, and were much less affected by mildew than others. In later experiments, he found that parsnips, salsify, radishes, and peas thrived especially well under the electric treatment, while turnips and beets responded to a less degree. Spechnu, having obtained such excellent results from the use of earth batteries, was led to perform the experiment of electrifying seeds before planting them, to see if the current would have any effect to make them develop sooner. He put some seeds into water until they swelled, and then transferred them into a glass cylinder, presenting copper discs against them at both ends. The discs were connected with the poles of an induction coil, and the faradic current applied to them for a minute or 2. Immediately afterwards, they were planted. Peas, beans, barley, and sunflowers developed in about half the time required for those not so treated, and the resulting plants were healthier looking, with larger leaves and brighter colors. The yield, however, was not increased. The results reported by other experimenters correspond so closely with those details in this chapter that we need not give them space. The small expenditure connected with the line of experimentation in electrohorticulture should make it popular.